What's up, guys? We're going to be making a simple antivirus here, and to do this we're going to be using basic static file analysis techniques. We're just going to be basically dumping the strings and then matching the strings up with a dictionary of malware signatures. We'll just be looking at some libraries that malware use, and strings commonly associated with malware. We'll be using C# for this, and I'm going to try and make this video as quick as possible, so to make it short and sweet. Okay, so some strings we'll be looking for in the binaries are create remote thread. Create remote thread is used to inject DLLs into remote processes. Sometimes the DLLs are injected persistence on the malware, aka to keep the process alive, the malware process alive. So yeah, this is a Windows API function, by the way. NT unlock view section, that's basically for this is also used in conjunction with this to inject DLLs into remote processes. Get async key state, this is used for keyloggers to see if a key is up or down. Yeah, you can view all the definitions on MSDN too. Get window text is also using keyloggers. It's using a feature in malware called smart keylogging, and that's basically to see if a window's active, and if the window's active, it'll capture users' keystrokes. For instance, if they only wanted to capture keystrokes for Chrome, they'd use that function. So this function is used a lot in keyloggers. Sit Windows hook X, this is using keyloggers as well to hook to the keyboard and to capture the keystrokes. Get a foreground window, this is also used in the smart keylogging functions, which is commonly used in malware, especially remote access tools. Regiondel manage, this is used in cryptors, and what cryptors are basically a program which will encrypt the bytes of someone's malware, and which makes it undetectable to antiviruses, as they don't actually see the original file and they only see the encrypted version, the encrypted byte version of that file. MD5 crypto service provider, that's also used in cryptors. These are Windows API functions here, whereas these are .NET libraries, so yeah, they're a bit different, and the way they're used is a bit different. Obviously these can't be used in unmanaged, well, they can, but yeah. So yeah, let's get started. So we want to have the dictionary of our signatures, so let's quickly set a dictionary up. Public static dictionary string. And we're going to set an enum up, and this enum is basically going to have types of malware. So types of malware, for instance, are keylogger, Trojan, cryptor. Trojan is a bit of a general term, but if it's not a keylogger or cryptor, we'll just call it Trojan. So we want our dictionary to be structured as in our signature and then the type of malware that it is. So we'll just have to have malware types here. Call the signatures. Equals malware types. Bang bang. Let's start putting our signatures in. Our first one, create remote thread. Window API function, and we'll just class that as a Trojan. NT map view of section. By the way, if you didn't know what NT was, NT kernel. We'll just class that as a Trojan as well. Get async key state, we'll class that as a Trojan. Get Windows text. Get window text, sorry. Well, that is associated with keyloggers. That Windows hook X is associated with keyloggers. get foreground window, which is associated with keyloggers. Again, to be honest, keyloggers are probably the most common as they're also integrated with rats or remote access tools. They're extremely common type of malware. Version down managed. They're used in managed cryptors, aka .NET cryptors. And MD5 crypto servers. I'm not really sure why they use that. Like, crypto offers use that, but oh well, their problem. Okay, so now we've got our signatures in here. As you can see, well, yeah, got a total of yeah, we've got a few signatures in here. I'm also going to add some like IRC commands, as IRC is a common protocol used for like control command, which is used to like control bots of a botnet. So I'm just going to put join in here, which is an IRC command. We'll just class it as a Trojan, obviously. Private message, which is also an IRC command. Class it as a Trojan as well. Okay, so we've got a decent amount of signatures in here, and as I said in the start of the video, this is static file analysis which we'll be doing here, which is basically just like reading the file and not like in runtime when it's actually running. So this is an example of like static file analysis, and this is like something I made earlier. This is like a quick example to show you guys. So yeah, like for instance, I've imported this Windows API function here, which we've actually added in the signatures. And this is basically just viewing the bytes of the file, then we're just converting it to a string here, which we'll be doing. And yeah, it's just a quick example to show you basically graphically what we'll be doing. So malware, sometimes they actually will drop into, well, most commonly they'll drop into a folder, and that folder is usually app data. So what we're going to do here is we're actually going to clean out this folder, because obviously we want all malware to like go away. So what we're going to do here, we're going to create a quick function, public static void, clean app data. Then we'll want to go through every single like executable file in this folder. So we'll just want to do for each var file in, and basically here we need to define where sorry, go back to where our app data folder is. So we'll want to do new directory info. Then want to do environment dot get folder path dot environment dot special folder dot app data. Actually, let's put this on another line. We'll just do, that's extremely ugly. I'm sorry I just did that. We'll do directory info. We'll put it here. I have no idea what I just did. That's disgusting. I'm gonna do i.get files. I want to put a wildcard here for the file name and .exe. Portable executables can also have, for instance, .scr. They could be built to that as well, but we're just going to cover executables here. So we'll just want to delete that, so we'll just file delete. But we'll also want to see if the process is running. So before we delete it, we'll want to kill the process, so we'll do for each process. Make sure you're also importing to some diagnostics here. We'll want to do process p is e dot process dot get processes by name file dot name, which is the file name, and we'll just want to kill the process. That's before we delete it. What we're doing here is we're going for every single process running, and then we'll just get rid of it basically, and then finally we'll delete it from the folder. We could also do this, for instance, for the temporary files folder, which is another folder commonly associated where like malware will execute from. So yeah, this is basically just clean app data. So yeah, now we're gonna make a quick function called clean running processes. So this is actually the big function which will use all your signatures here, and it will basically go for every single process that's running, and then we'll get the location, we'll get where it's actually on the disk, and we'll read it, and we'll match it up and see if it matches to any of these strings here. So let's start off. This is going to be, yeah, as I said, well, I don't think I said this, but I don't really care about object-oriented like standards here or anything. I'm just doing this quickly as like a proof of concept basically. So what we're going to do here is we're going to enumerate for every single process. So we're going to do process p equals in process dot get processes function. Okay. So then we're gonna get the process where the actual process is on the disk, which we're just gonna make a new string, and we're gonna call it string process location equals p dot. Sorry, what am I doing? P dot. Sorry, I can't actually remember where it comes from. Sorry, one sec. Oh yeah, main module.file name, sorry. I just had like a moment there. This is basically where the process is running from, where it is on the disk. So then we'll want to go for each of these signatures and see if it matches up with any of them. So we want to get the bytes of that, the bytes of the file, and we'll make a byte array, and we'll call it file bytes equals file dot read all bytes process location. And this will just, as it says, read all the bytes of the file, and then we'll want to convert those bytes to a string. So we'll do that by string file strings equals encoding.utf8 get string, and as the parameter here are bytes of the file, and then we'll want to go for each of our signatures now. So for each key value pair, during malware types, signature in signatures. Okay. And then we access the signature, and then we'll do if file strings dot contains our signature. That's signature dot value. Sorry, key. What we're on about. Infected. Actually, I'm not sure why I put this as a void. Yes, I do. What am I on about? Sorry, I just had a moment there. We're just gonna display console.writeLine, string.format, process is infected, is malware. What am I on about? We'll do p.name, p.name module dot file name. So what we're doing here is we're just displaying that it is malware console. And we'll also, yeah, okay. So it contains signature, which we've put up here. And then we'll want to get rid of that, and we'll want to kill the process and delete the file. So we'll just do p.kill, and we'll want to do file.delete, and we'll want to do p.main, main module.file now. Okay, so I'm also gonna put here console.writeLine, malware. Sorry, I'm not actually sure why on earth did I do that. Malware file.name. Okay, so let's just take a look at the app data first. That's console.readline, so it doesn't exit immediately. So as I said earlier, we've got our binary here, which is an executable here, description virus, whatever, OMG virus. Oh my god, virus. Click F5 and debug it. We'll build it first. As we see here, it's displayed that we've actually found an executable in app data, and if we go back to app data, it's gone since we've deleted it, and we've also displayed it here. And let's actually run something in the memory. Sorry, let's run something. So virus, and we'll run this. So as we can see, our app data function is working, and then we'll just clean the running processes down. This should work. See if I've done anything stupid here. And also, we're gonna access this. See if it's like, yeah. Let's start. And oops, what's happened there? Okay. Chat times. But yeah, that would happen if you're running as like administrative. But yeah. Also, an antivirus would be running as admin. So yeah, as you might have not caught that, but it did display that it had found it. I'll just comment this out. Oh yeah. We'll just wrap a catch around this. In case we try and access anything we shouldn't be accessing or don't have permission to access. So here. So yeah. This is some of the stuff which is killed. Also, you'll get some false positives, as for instance here it's killed Atom, and it's also killed yeah, that's pretty bad. But yeah, it's killed our virus anyway, and it's cleaned app data, it's cleaned running processes, killed it, and yeah. Sorry, this has kind of been brief, but this is like all the time I had for this. So yeah, I'll probably make like an updated version of this. This is really like quick and scrappy. So it's not proper, and this is basically just showing you how to do it and giving you like headway.